All right, welcome to chapter 16. It's our last chapter of the year. We're going to cover some ideas from probability. A little bit of this will hopefully be familiar with some basic probability concepts that you've done in the past. Um, some of it will certainly be new, but hopefully it won't be too challenging. Probability can be really confusing and counterintuitive at times area of study. So be patient with yourself. Ask questions of me as you need to, and hopefully we'll be able to do fairly well and be comfortable in this chapter. So let's start with the really most important basic idea here called the counting principle. The counting principle says that if one activity can occur in any of m ways and the second activity can occur in any of n ways, then both activities can occur in the order given in m times n ways. So m and n are specific numbers. So like this could be 6 and 4. So we're saying if the first thing could happen in 6 different ways and the second thing could happen 4 different ways, then the number of different ways they could both happen is 24 different ways. So something basic like if I have 10 different dress shirts and 15 different ties, then I have 150, 10 times 15, 150 different ways of combining my shirt and ties. Like that's what the counting principle says. All right, so we're going to have to define some terms as well. So the result of any given activity is called the outcome. The outcome. The set of all possible outcomes is called the sample space. Let's see some examples here to put those into context. It says a penny and a nickel are tossed. We know that a penny, if you flip it, could land heads or tails. A nickel, if you flip it, could land heads or tails. So an outcome would be the particular result of one flip of each coin. So suppose you flip the penny and you could get, so the penny could be heads or tails. The nickel could be heads or tails. So if the penny came up heads and the nickel came up tails, this is one particular outcome, one possible outcome. Okay, the sample space is the list of all of the possible outcomes. So the sample space would be to say, all right, well, let's do, I could get heads on the penny and heads on the nickel. That would be one possible outcome. Or I could get heads on the penny and tails on the nickel. That would be a different outcome. Another outcome would be tails on the penny and heads on the nickel. And then the last outcome possible would be tails on the penny and tails on the nickel. Okay, so each of these pairs is a possible outcome. The group of them all together is called the sample space, right? So outcome, outcome, and so forth, right? These are individual outcomes. The whole thing is called the sample space. Okay, so some important terminology to make sure we have a grasp on here. You'll notice for the penny there's 2 possible outcomes. For the nickel there's 2 possible outcomes. 2 times 2 equals 4. That's the total possible number of outcomes. So that's how many items there or how many outcomes are in the sample space by the counting principle, right? If there's 2 ways the penny can flip and 2 ways the nickel can flip, then there are 4 ways that they can flip when they flip together. So let's keep working on sample space. Let's do another example. A coin is tossed and a fair die is rolled. Okay, so the coin has 2 possible outcomes, right? The fair die, in case you were not aware, a fair die is a 6-sided die, 1, 2, 3, 4, 5, 6. So what we mean by fair is that all sides have an equal likelihood of coming up. So we would say a fair 6-sided die has 6 possible outcomes. And it wants to know what is the sample space. Okay, So let's just note our outcomes. Our possible outcomes for the coin flip are heads and tails. Our possible outcomes for the die are 1, 2, 3, 4, 5, and 6. So our sample space, and in case you're worried, we're not going to spend a lot of time listing out sample spaces, but just right here at the beginning to make sure we're really comfortable with what a sample space is. So when we start saying things like, oh, I draw 3 cards out of a deck of 52, well, that has hundreds or thousands of possible outcomes. So we're not going to list sample spaces like that, but just to make sure we understand what a sample space is, that's what we're working on here. So a one possible outcome is that I got heads on the coin flip with a 1 on the die. I also might have gotten heads on the coin flip with 2 on the die. I also may get heads on the coin flip with 3. I may get heads in 4, heads in 5, or heads in 6, right? Those are all possible outcomes where the coin lands on heads. I also might get tails with a 1, or tails with a 2, or tails with a 3, tails with a 4, tails with a 5, tails with a 5, or tails with a 6. And those are all of the possible outcomes. So this would be my sample space here, all of my possible outcomes. Notice again, the coin has 2 possible outcomes. The die has 6 possible outcomes. The counting principle says if I multiply those together, I get 12 possible outcomes, and that jives with the sample space that we just delineated, right? There were 12 different pairs here. Each pair represents a possible outcome. Okay, so there is the counting principle and a brief discussion of sample space, and we want to make sure that you know how to delineate the sample space and maybe more relevantly think about what all the possible items in the sample space could be. You'll practice some of that in the homework, but we're going to continue on in the next video with different ways of representing the sample space.